My name is Rob Jackson. I'm a climate and environmental scientist at Stanford University in California. I was trained originally as a chemical engineer. I worked for the Dow Chemical Company right after college, but then went back to graduate school to study environmental sciences and to become a professor, and I've done that for the last several decades.
And your focus now, the main work that you do now?
Most of the work we do now in my lab deals with greenhouse gas emissions, measuring them and trying to reduce them. We also do ecology, looking at how climate change is affecting forests and grasslands and natural systems too. But mostly we measure methane and carbon dioxide and nitrous oxide emissions from on land and in energy sector in buildings and homes and from oil and gas wells.
Why did you decide to focus on methane in particular?
Well, I focus on methane because it's the second most important greenhouse gas in terms of causing warming today. It causes about 2/3 as much warming as carbon dioxide has. But it's also the gas for which we have the most opportunity or the biggest lever to make changes in the next couple of decades. There's 1 trillion extra tons of carbon dioxide in the atmosphere that's not going anywhere anytime soon, and it'll be there centuries from now. But for methane, if we could cut all human emissions, the atmosphere would go back to normal within a decade or two. Methane is much more potent than carbon dioxide, but it's also much shorter lived. So what we do today has a much more immediate effect on the atmosphere.
With what's going on with methane at the moment, can you just explain the potential risks that we face if we don't address it?
We need to address both methane and carbon dioxide. We're already well on the way to surpassing a 1.5 C temperature threshold of increase, and heaven help us 2 or 3 degrees C. It seems to be where we're heading without immediate action. We need to reduce methane from the energy sector, where about 1/3 of human-caused emissions come from, and also the food or agriculture sector. Surprisingly, that's where most methane enters the atmosphere, from cattle and other ruminants, from their burps, from rice paddies and systems like that. Those sources, particularly cattle, are as big as the oil and gas sector.
What's your opinion of the risk that we reach a kind of a tipping point with methane release?
I'm very concerned about tipping points of several kinds. Let me start over. I'm very concerned about tipping points.
Sorry, I just want to stop the.
Yeah, I'm very concerned about tipping points of climate. There are obvious tipping points for ice melt with glaciers collapsing in Greenland and Antarctica. But Arctic systems have a different kind of vulnerability. There are thousands of years of carbon stored in permafrost systems that from the plant growth over many centuries. And that carbon is locked up in frozen soils. And as the Arctic thaws, much of that carbon will become available to microbes and it'll decompose. And we don't know how much of it will go into carbon dioxide and how much of it will be turned into methane. Both are bad. But if more of it becomes methane, that's really bad. And I think that's one of the tipping points I'm most concerned about, would be runaway permafrost thawing and a rapid increase in the Earth's methane levels.
That you're working on to reduce or remove methane?
Well, we spend most of our time trying to stop methane emissions today. I work in homes looking at appliances like stoves, furnaces, and water heaters. And stoves, for instance, not just release methane and greenhouse gases into the atmosphere, they release indoor air pollutants like NOx gases and hydrocarbons that we breathe that triggers asthma and other diseases. So I want everyone to think of climate solutions not just as helping the environment, but improving our health. My group also works on methane emissions from oil and gas wells and transportation and all kinds of other sectors. So we're trying to find that methane and use aircraft and satellites and mobile measurement systems to put pressure on companies and help them identify leaks and squish them or squash them.
What in general terms, what are the main barriers to achieving this?
I think one of the main barriers is there's no price on methane. Companies and people don't pay anything for the methane we release into the air. An oil and gas well that leaks gas into the air is free. So we need to change that and put a price on methane in the same way that we need a price here in the United States on carbon dioxide pollution. As long as greenhouse gas pollution is free for companies, there's no incentive, no financial incentive for them to act. So we need to price our pollution. We also have technology needs one good example today is that there are new satellites launching that will help us find large sources of methane, what we call super emitters. These might be a landfill or a concentrated feedlot or dairy operation, or an oil and gas facility that are belching huge amounts of methane into the air. We don't have a way right now to find those sources quickly, and satellites are going to do that for us, especially for the largest ones.
Can you go through those? You mentioned in one of the talks, or one of the presentations that you gave some of the methods that are being explored for methane removal.
Yeah. One thing I'm excited about now and that we work on a lot is looking for technologies and ways to remove methane from the atmosphere and also from dilute sources that are emitted from human activities. And we can do that using catalysts to take a parcel of air and use a catalyst that targets methane and oxidizes it, turns it into carbon dioxide. And it's important to remember that every molecule of methane we release into the air becomes carbon dioxide naturally. All we're trying to do with these technologies is to speed that reaction up. And because methane is so much more potent than CO2, that reaction is desirable. It makes sense. So we're looking at catalysts, metal catalysts embedded in zeolite clay lattices. Titanium dioxide and other photocatalysts can help us do this too. There are biological approaches. Microbes oxidize methane and convert it to carbon dioxide naturally in soils. So perhaps there are ways to use the power of microbes to help us do this. And finally, it may be possible to increase the levels of detergents or cleansing molecules in the atmosphere, like hydroxyl and chlorine radicals that destroy methane naturally. If we can release those in point sources, we may be able to target methane destruction in particular places in the atmosphere. There's a lot more work to do in these technologies.
Some of the challenges, in particular, the aerosols, just understanding what scale means, or the consequences of scale.
The biggest challenge with all removal technologies, whether it's carbon dioxide or methane, is the scale that it takes to make a difference. If you want to eliminate hundreds of millions of tons or billions of tons of those gases, you have to process enormous amounts of air to do that. And so releasing aerosols, for example, into the air means we have to look where those parcels of air go. We need to make sure that we don't release unexpected gases, that we don't turn inert nitrogen into NOx pollution or other things. So we have to be very careful in deploying all these technologies to use them responsibly and to give people a chance to have input before they're used.
Can you just share your thoughts on, if we just go as we're going at the moment and just manage to achieve net zero by 2050, that alone, do you think that's sufficient, or do you think that we've really got to accelerate?
Well, achieving net zero emissions for all greenhouse gases by 2050 would be marvelous. I don't think it's enough. I think our goal should be to restore the atmosphere, ideally to pre-industrial levels. That's my dream for working with methane so much. I would love to see methane restored to previous concentrations in my lifetime. That's something that's not possible for carbon dioxide because there's so much extra CO2 in the air, 1 trillion tons worth. But for methane, if we could get rid of all extra methane emissions today and do some atmospheric removal, we could see the atmospheric concentration of methane go back to where it was 2 centuries ago within about a decade. And that's both exciting and a great motivator. It's also an amazing opportunity or lever for us to keep global warming from sort of running out of control and for reducing peak temperatures over the next 10 or 20 years. It's a really amazing opportunity.
There's been some pushback to a degree on removal because people saying that it's just going to give industry a get out of jail ticket. What are your thoughts on that argument?
Well, I think the moral hazard argument, as we call it, is important. You don't want companies to be able to say, well, I'll emit my pollution today because someone in the future will be able to remove it from the atmosphere. We want to keep those gases out of the atmosphere right now. But nonetheless, if rapid methane release from the Arctic happens, or some other unexpected increase happen, for instance, in tropical wetlands, we don't have a technology right now for dealing with those increases. And I think methane removal as a potential technology gives us that opportunity. It's an insurance policy to run away methane release, or a lack of human action, frankly.
Do you think there'll come a time where there's methane credits, and just in terms of credits, I mean, there's such bad press these days with, TNC, selling carbon credits to forests that it's already knows aren't going to get cut down and stuff. So it's really getting a bit of a bad name these days. But nonetheless, do you think there's room for maybe a methane credit system?
I do think there's room for a methane credit system. And if we can destroy methane with the technologies I've talked about, we can verify that destruction, and there's no issue of permanence. The methane goes away forever, and we know that and can verify it. So I hope sincerely that there's a price on methane and that there's a market established for the destruction of methane.
Okay, great. Just on a real personal level, where do you feel we are? How do you feel about the future?
You have to be an optimist to be a climate scientist. Otherwise, you couldn't get up in the morning and couldn't work in this business. I'm excited about many things that are happening. We're seeing action on methane. The Global Methane Pledge that was launched last year at the Glasgow Climate Conference is a major step forward. We're now about 120 nations have pledged to reduce methane emissions, about 30%. I do believe that a price on methane and ultimately methane credits will be valuable to help people cut emissions. And we may not be able to eliminate emissions from the food sector, for instance. Growing food, particularly cattle and rice farming, releases methane emissions right now, and those may be very hard to get to zero. For that reason, and for other hard to eliminate emissions in the energy sector, I think we need a market that allows us to trade methane emissions. If you can eliminate them somewhere else, where it's easier and cheaper, and verify those cuts, I think that's a valuable thing to do. And methane removal is particularly well suited for that because of the technologies we use. You can show or prove that a certain amount of methane is destroyed. There's no uncertainty or ambiguity about that. Well, I pray that by 2050, carbon dioxide emissions are net zero around the planet. I think that's unlikely, but that's a goal for everyone. And my dream would be for us to see methane concentrations in the atmosphere drop back to pre-industrial levels because of cuts in methane emissions and judicious use of methane removal from the atmosphere where it's needed. So we have an opportunity to reset the atmosphere for methane, and in doing so, to reduce temperatures by a half a degree C or more, or a full degree Fahrenheit. There's no other way we have in the short term of a decade or two to do that. Methane is a pyramid. It has a carbon atom in the middle and 4 hydrogens that make the pyramid, or the points of that pyramid. It's a very potent greenhouse gas, and when it's broken down in the atmosphere naturally, it turns into carbon dioxide. So those hydrogens go away and 2 oxygens bond to the carbon molecule. Methane is destroyed by nature's natural detergents. These are radicals, molecules such as OH or hydroxyl and chlorine. They are able to break apart the methane molecule and convert it to carbon dioxide. They essentially react it with oxygen, the same way that your stove or a flare burns methane and turns it into a CO2 gas. These detergents do the same thing.
And then just again, a kind of a 101 thing. Some of the methods that you were talking about earlier, those methods in themselves, are they generally kind of using the same type of mechanisms that nature does?
Some of the mechanisms do mimic nature. In fact, most of them do. We can produce additional radicals, the detergents that destroy methane. We can use microbes to destroy methane. And even many of the catalysts that are used industrially, they're patterned after catalysts that exist in nature, including those found in microbes. So we look to nature for ideas in how to destroy greenhouse gases.
That's great.
I write poetry a lot. It's a way of understanding the world around me, and it's a way of remembering things. It's also a source of hope for me. I need to find ways of communicating and processing the world, not through peer-reviewed articles in the science that I do, but in other ways. So poetry is one of those. Much of my poetry is hopeful, but sometimes I write something out of frustration. That's the source of this poem, which is Climate in Action. The poem is called Climate Stasis. It was published in a journal called Light. So climate stasis. We waited, delayed, hesitated, procrastinated, prognosticated, obfuscated on thin ice, dawdled, stalled, free-for-alled, protocoled collect, dropped balls, stonewalled, mitigated communities, modeled, dallied, rallied, death valleyed. Risked, bet, staked, gained, gambled, generally wagered all. We broke bad, faith, dreams, records, ranks, and the bank.